Hello everyone and welcome back to CodedByJade. In this video, I want to talk about what maths modules are like as a computer science student. This video is mainly targeted towards if you're about to attend or are thinking of attending a university that offers a maths-heavy computer science program, which you can find out by checking the program details on their website. Before we get into the video, be sure to like this video and subscribe, and also follow my Instagram at CodedByJade, where you can DM me for personalized advice. So I'm going to go into an overview of what I've learnt. The first year of your computer science degree should typically introduce you to a range of maths topics, which you will apply in later computer science topics as your degree progresses. This can range from discrete mathematics, graph theory, linear algebra, logic and proof, and probability and statistics. In my experience, I had two maths modules, and these were named Maths for Computer Science A and Maths for Computer Science B, and these were 20 credits each. I'm going to break down what each of these modules consisted of, including class structures, content, problem sheets, and what helped me throughout each term. I also had a module on algorithms, this module being 10 credits, and this was also very mathematical, so I'm going to include it in the video too. So, talking about module structure, for both pure maths modules, I had two 2-hour in-person problem classes a week and one office hour per week. Each problem class had a problem sheet based on the previous X lectures from that same week or over the weekend. So now I'm going to talk a little bit more about Maths for Computer Science A. Maths A was split into two halves. The first half included topics Introduction to Proof and Logic and Set Theory, and the second half of the unit was Combinatorics and Probability Theory. So these involved the following topics such as propositional logic, predicate logic, quantifiers, types of proof, set theory, functions, combinatorics, probability, and probability distributions. If you're about to start university and your course has a similar module, then I would suggest that the best way to prepare is to use Brilliant.org's Introduction to Logic course, read up on combinatorics, as well as brush up on your calculus skills to help with probability distribution topics. In this module, I was recommended the book Discrete Mathematics and Its Applications by Kenneth Rosen. And this book had extended content from the lectures, which helped me review what I was taught in the lectures. And there was also a ton of extra practice questions, which helped me practice my problem solving skills across these topics ahead of exams. I was also lucky in this unit for the fact that the unit director scheduled 2 to 3 practice exams, so we got an idea of what the exam questions were going to be like. We had a January assessment where the question style was a mixture of multiple choice, multi-select, and input box questions. Okay, now on to Maths B. In Maths B, we were also given notes on top of the lecture videos materials, which went over the same information, and this meant I didn't have to write as much notes as in Maths A. The unit was split into 3 sections. The first section was linear algebra, the second section was analysis, which pretty much calculus and complex numbers, and the final section was about statistics. So to go more in depth about the kind of topics that you could expect to learn, linear algebra included angles and the dot product, geometry, vector spaces, orthonormal bases, matrices, linear systems, and eigenvalues and eigenvectors. Analysis included calculus, complex numbers, and differential equations. And statistics included parametric and non-parametric tests, hypothesis testing, and how to criticize papers. For this unit, we were recommended the book Introduction to Linear Algebra by Gilbert Strang, but in my opinion, the course material was more than enough to achieve a first class. To prepare for your university's rendition of this course, I would say to make sure that your knowledge, recall, and understanding of what you learnt in A-level maths and further maths is very strong. I would also recommend the video series Linear Algebra by 3 Blue 1 Brown to help you prepare for a similar course. He does a good job of explaining and visualizing the context of any introduction to linear algebra related units. And finally, I'm going to discuss my course Algorithms 1. Algorithms 1 was an introduction to the analysis of algorithms and algorithmic design. In this module, we were not only introduced to data structures and algorithms we may use in day-to-day code, but also how to perform mathematical computations on them to calculate their runtimes under different notations such as big O, theta, and omega. We were also given questions to test our algorithmic design skills, where we had to design algorithms to solve certain problems to be run in a certain time complexity or have a certain space complexity. And in fact, in this unit, we did not do any coding at all. If you wanted to code up any algorithms or data structures learnt, then this was to be done in your own time. This unit had one worksheet a week, and we reviewed our answers with teaching assistants weekly before the example answers were posted afterwards by the lecturer. We also had one office hour per week and an online forum to ask the lecturer questions directly. So, just to discuss the kind of topics we learned in algorithms, this included searching and sorting, such as merge sort, quick sort, binary search, linear search, random access models as a computational model, trees, runtime complexities, and dynamic programming. For this unit, we were recommended the book Introduction to Algorithms by the MIT Press, which did a good job of breaking down the mathematical analysis of algorithms and how they work, but it is a heavy read. It also had a lot of questions you could practice to further your own understanding. This module involved a summer assessment, and in my opinion, the worksheets weren't too necessarily helpful in answering the questions to a high standard. I recommend looking at the further reading and make sure you've truly understood how each algorithm works by familiarizing yourself with the pseudocode and how each line in particular works in detail. Okay, so that was an introduction of the kind of maths topics you can expect to be taught as part of your computer science degree in university for those studying more theory-based computer science courses. Don't forget to like this video and subscribe for more content, and I hope you enjoyed. Bye!